Alright, making a video. Draft physics and such. Yes, it seems to be recording. So, alright, I guess I'll do some comments and then mostly on the subject of just the basic functions of the small universe, because that's really the only universe. So I just keep emphasizing that point. but everything that happens down there first. And that's where it gets really simple, mechanical processes and such. So, comments. Mouse that works, please. Okay, that one, oh, not that much left there. A little bit more there. All right, anyway, okay, Robert Ritchie. I have a atypical view of even gravity is quantized, i.e. graviton. So, I mean, there's no point in saying the word graviton without describing what you mean by it, because obviously regular physics has a really bizarre description of a graviton as some sort of anti-particle-y thingy. You know, it doesn't really have anything to do with the ton word at all. So, it's kind of like a gluon or something. You know, it's some kind of, you know, makes attraction and repulsion, does all kinds of, it's not what they make it sound like, which is force or rain falling down on you. So anyway, I have no proof. Well, nobody has proof, quote unquote. What should rule the day or win the day is the most reasonable argument, and that's all we can seek is reasonableness, and I don't see any of that though, frankly. Just my own theory. Well, like I said, it has to be based on something. Your concise description of electricity current and voltage holds true for electron or proton flow in solids, liquids, and gases. Proton flow, I don't know where you got that from. And the electron flow, as I described, was very meager. The electrons are pushing on each other, so you could theoretically say that eventually in a DC circuit they would push some electrons to a location. But the amount of electrons moving is sort of secondary to the amount of force that's moving through that process. So for every little tiny movement in an electron, you have a big movement in terms of the force being cascading down the wire. I certainly don't suggest any proton flow at all. The atoms themselves are not moving. So the protons are essentially deciding the center of gravity of the atoms, and so the atoms aren't moving anywhere and the protons certainly aren't going anywhere. Except in the case of proton flow in solids, which has not been observed. Again, where did I suggest protons do any moving? I never even came close to saying it. So I don't even know how you got the idea that I implied it. They're stuck in a nucleus that's really dense in most atoms, and it's not going anywhere because they're all, you know, in one place, and you'd have to move them with force that could localize on that one location. That ain't going to happen. That ain't going to happen through any other process than first moving the electrons. You got to move the electrons to move the protons. I agree with you on photons. To destroy, the word destroy just doesn't. Anyway, the photon wave theory. For all time, we must ask the wave proponents. You know, you gotta make it, you know, to destroy the theory. Again, you have to replace it with something, and that's all you have to do. Just as I replaced the theory of interference for the radar experiment with the much more rational theory of jamming, and therefore you don't get into this trouble of having to create a whole new quantum mechanics where you don't need slits anymore to cause wave functions. So you don't have to go there. You don't have to introduce new physics to explain the experiment. And the same thing has to be done with these other experiments. A better alternative has to be provided. And ask the wave proponents, if an electron emits a photon as a wave, then how can that wave be visible after billions or more light years of divergence? Well, they won't concede that the wave is diverging. They do the whole whatever, this kind of, somehow it's a compact wave. It's just doing this kind of stuff. It's waving like this and like this, but it's not really waving somehow. And whatever it's doing to the electric field, it's just wobbling the field somehow. Of course, there's no evidence for any field effects from a photon. The evidence is you only know of a photon's existence when it plows into an electron. It has to plow into it. Can't brush up against it, can't do any funky stuff, has to hit it. Otherwise, photons don't exist. Alright, Mark, static. Close enough. Hello, Gary. I'm amazed how few people know about any physics of AC and DC systems, specifically both because how else can you recognize and fix errors on our current simplified model of physics? I don't know exactly what that meant, but okay. Just today heard how brilliant Tesla was. And I pointed out that no, he was not. Probably, but wrong reasons. Yeah, he's obviously, Tesla was smart, but he was also, as a lot of eccentric people are, a bit crazy. And so his reasoning skills were myopic, you know, and that's a problem we all are vulnerable to, you know, is to, you get glued to an idea too strongly, and you know, you're just not able to bend with the new facts. And Tesla was incapable of recognizing that his childhood delusions about how electricity worked just weren't right. Only argument I got back was that otherwise we wouldn't have phones or computers, right? The same old dodgy bullshit. Everybody thinks they invented everything with one idea, and now it's a lot more than one idea. It's so clear when one knows even a little bit about AC and DC. Edison. Well, clearly Edison did a lot of road paving, and you know, people can pretend he's just some crook, or just this, or he's just unfair, or he bully. But you know, it's just idiotic not to realize that he put together a group of people, good scientists, and they did good science. It's a mess for sure, and that's my opinion about physics went wrong, and it has. You know, the going wrong part is it's a long, wrong story. You know, it starts probably with Newton, and you know, they didn't do debating very well back then either, even though they had, at least they had the debates. But you know, it's just too fickle. What physics decides to say is our platform is too fickle. And then you could clearly see, by the time you get around to Eddington, you know, in the early 1900s, this all physics became political. It was you know, the Newtonists against the Einsteinians, and you know, all kinds of camps, and so it just became a political battle, and a lot of those are always won with propaganda, you know, with lies. And essentially the Eddington experiment was a lie, you know, in terms of what it demonstrated. And certainly the whole interferometer thing, Michelson-Morley, it's just not a good enough experiment to make declarations, and they just piled way too much on these small bits of information, making redshift into an excuse to, you know, embiggen the whole universe into something, you know, a bunch of expansion that doesn't necessarily have to exist. There's certainly a bunch of velocity that you can't account for. Anyway, better explaining force and function of it than what you have takes a bit of work, but well worth it. My English needs work. Try and change that. Take care. Well, I admire anyone who speaks more than one language, and so I certainly couldn't be bothered. You know, I took 2 years of Spanish, and I can count to 10, maybe. I mean, I can count to something like 10. My interpretation of your theory predicts that while two electrons move together, the faster they move. Well, that would just be retarded. First off, they don't move together, they have to be pushed together. And as I've described quite clearly, is they're like mirrors, they're ping pong paddles. If they move together and they're reflecting something back and forth, the reflections are going to increase dramatically. You have the distance, you double the force. I mean, have the distance, double the force. So yeah, they're not going to move faster towards each other. They're going to be slowed down dramatically as they move towards each other. The weaker the repulsion between them gets. So again, how did you interpret my theory to say that? I just don't know where you got that from. I mean, I've done this ping pong paddle thing so many times and talked about the reflections and how this is the whole idea of what resonance is doing. So when you get a resonant frequency, it means you're at the frequency where you're maintaining the reflections. And when you have a frequency that's a little off, then those are destructive because the push and the pulls are fighting against each other and essentially releasing the energy. Where if you keep the reflections perfect, then that is your resonant frequency, and you maintain more energy because it keeps reflecting. The whole idea is to keep it reflecting. It's not the idea, but I mean that's the implication of it. But clearly, I've said I just don't know how you can say your interpretation. That somehow I said something that would make somebody think that electrons get closer together. They like to be close together. When no, the closer they get, the more they want to get the hell out of there. All right. The weaker the weaker the repulsion between them gets. So he's saying the closer they get together, the weaker the repulsion, when it's exactly the opposite. Same argument for two magnets. So again, I just don't know how you could possibly twist what I said into that interpretation. It just, people do amaze me in terms of, do you listen at all? I don't know. I don't know how. I watch my videos and it seems clear to me what I said. I just don't know how you're making those big of mistakes. I don't know how I can say it any plainer. So it is irritating. Alright, so I don't think we have anything else to comment on. Might as well just check the subscriptions quickly. Bill Gates did a video on numbers, but it was all kind of boring. I mean, people can have theories about math, but math is just a simplification. It's just a way of taking a circumstance that has certain elements, and it's just a way of symbolizing things and representing them in simple ideas: 2-ness, 4-ness, 10-ness, and then sets, or you have a quality of being mutually tend. You're tenorized. And now what happens to things that have the tenorized? Well, then you can have 10 tens. And it's just it's a mechanical process of it's almost a kind of language, mathematics. A kind of vocabulary that allows you to identify things and recognize the relationship between those things, that these things have relationships. But it's neither a philosophy, or it's just a functional language. And like any language, you can make up bullshit terms and formulas and words. We have language, and we have lots of words in it: spontaneous, random, love. Don't mean anything. Garbage, junk words. And you can have junk formulas and junk. You can misrepresent reality in your mathematical language. Alright, so enough of that. Piro did some, I don't know, hour and a half of boring drivel on his philosophical mushiness. So, drawing. Yay, lizard. Alright, so I thought I would just talk a little bit about the basic systems. And so for this purpose, we will just confine ourselves. We'll start anyway with a simple idea. So let's just say the universe, the only thing in the universe was the electrons, as represented by this. Yeah. And we'll say the electron force, which you could just represent as a little that, you know. And that always has a momentum vector. It's moving in a direction. And the electron doesn't have any innate vector, but it collects vectors. So it has a history, and it has a capacity to make exchanges. So you could think about it as like a drop of water, you know. And in a way, you know, you have this blob of water in space, like in a space station, and then you're going to shoot other blobs of water at it, and they're going to become part of the big blob, but the big blob is going to react by shooting out some water in the opposite direction. Now, in the space shuttle, you won't get that real reaction. You'll get small pieces, you'll get all kinds of, but it's a quanta thing. So in the real universe, the blob, that is the electron, absorbs the energy, and it will give back exactly what it absorbed eventually. In the sense it will give back something going forward. Okay, eventually. Alright, so, but if you just had a universe of electrons and the force, okay, you could sort of understand that you could sort of understand that everything just equals a reflection. So everything that hits the electron just reflects back out, and there would be a perfect equilibrium. That is, as many things going in as things coming out, and it would all be perfectly symmetrical. And the implication of that would be is that each electron would find an equally distant from each other. So all the electrons in the universe eventually would all be the same distance from each other, because any imbalance would force them to move towards each other. That would have to be dealt with because that's more pressure. That pressure would have to be spread throughout all of them, blah blah blah, and so they'd eventually just end up all being exactly the same distance from each other. And that would be the shape of the universe, is that it would just be a bunch of these electrons equal distance from each other, and they'd all just be at equilibrium with the environment, in the sense they would be absorbing the same amount of energy as they're reflecting, and they'd all just sit in that state of, this is the universe, it's just static and at these distances. Now the truth is, the real universe isn't much more complicated than that. I mean, all we're really going to do is add a protons and we'll add another color force, but that's all that's going to change, is we're just going to add another couple of rules, and it's not going to be much more complicated than that. But it does have implications for the fact that you can create a lot more difference in how these things are going to end up being arranged because of that, because now you'll have the capacity to compress things into different sizes. Alright, so one of the implications of this electron rule is that you could sort of surmise is that it might explain why so much of the energy spectrum, say the electromagnetic spectrum, you could say that that whole spectrum is just heat. You know, from radio waves to gamma radiation, it's all just heat. It's just all a kind of heat. And it all has to be somehow created by these atomic mechanisms. And even in this, even when you're saying, okay, there's an atom, the basic rule is that probably the atom is still representing this distance force. Generally speaking, the electrons probably have the same amount of force between them. That is the same amount that would have been if all the electrons were just in a free universe at a distance. And so they'll tend to have that same pressure being realized to some extent in the atom, and the only thing that really changes it is this attraction to the proton. So you can see that it could get compressed, that is, the force could be they could be a closer distance to each other the closer they are to the proton, and the further away they are, the less compressed they are in terms of how much force they're compressing. And realistically, somewhere the average inside of that each atom, the average would be essentially this universal distance. The distance that the universe creates is the pressure based on the number of electrons in the universe, and well, what's really changing it is the fact that now they're also in compressed locations. So instead of spread out across the whole universe, they've been consolidated, and through that consolidation it means they're closer together, but the amount of pressure between them is still the same. So so it's like the ping pong paddles, right? So there was a certain amount of energy in the, if the universe could, if all the matter wasn't in clumps but was just free, the electrons were all free, they'd have a certain distance, and it's because they're not free and that they're consolidated, that distance is compressed, but the same amount of force still exists. So they have a will to expand, they have a capacity. So that's just the nature of the atom, being like a battery. It's taking a force that should be here, you know, and it's compressing it to here to make an atom. Alright, so it didn't do that perfectly, but it's close enough. So the part I wanted to, so yeah, yeah, this is so, it's simple, but it's, you know, there are 4 parts to it, you know, and this is what confuses people. All right, so in the atomic world, as we know it, the protons, okay, are very close together, so they're violating, so they should also have this great deal of distance based on their constantly getting hit by this red force. And the red force does exactly what the blue force does to the electron. It just reflects, so they're at equilibrium, the same amount of stuff going in, same amount of stuff coming out. So they're just radiating the world that hits them. They're at like a temperature equilibrium with the universe, theoretically. Yeah, and so, but to get them close together, all right, this is where the neutron comes in, because the neutron has the extra electron, okay, that allows for the pressure between these 2 protons to escape, and therefore they can stay in this permanently close proximity to each other. So basically the nucleus is just a bunch of these protons very close, because there's a bunch of, not a bunch, but there's an equal number of electrons that are part of the neutron. Alright, each neutron is essentially a proton and an electron. So these pairs allow the whole thing to get very small. So now you have this positive charge in a very condensed condition. And now it's going to interact with electrons, you know, that are at some distance. And so the distance is going to be dictated by these pressure rules of how much pressure can be between the electrons and the amount of attraction at that distance. So you have 2 factors. You have how much the electrons might oppose each other, and then you have the attraction to the now condensed proton, which is creating a pretty condensed kind of it's a very good at letting, certainly it's very good at getting rid of all the any blue energy coming into it, because of the condensedness. Doesn't ever get to this electron because it just has no chance, because there's so many protons here that it's all going to leak out before it ever sees this electron. So it's creating a very dark shadow on the electron in terms of it's not going to get any energy coming in this way. So it's going to radiate energy, but it's not going to get any energy from that side. And how much it radiates is also going to be limited. Alright. Now this is it's going to get complicated, more complicated than I want to get for this description. But anyway, this is all that's really happening. It's just these little bits. So the electrons and the protons and the force are the only thing constructing everything else. And the rest is just constructed out of the pressure changes that you create by mixing these two objects. So I just draw this one more time for simplification purposes. Alright, so it just needs to be understood that the fundamental force is that if if it's electron on electron, you end up with a lot of reflections, because they all reflect back and forth, back and forth. If it's electron on proton, all the blue energy escapes in one of the perpendicular dimensions from the proton, and all the red energy escapes from the electron in a perpendicular direction, so no reflections. So there's no reflections here, and all reflections here. And that's what creates what we call attraction and repulsion, which really is just low pressure and high pressure. The high pressure of a constant reflection, the closer you bring them, the more force you create just by proximity. And the fact that no matter where, the closer the electron and the proton get, the more energy escapes, the more certain that you're going to lose anything trapped between them. The blue energy is going to go out through the proton, and vice versa. But clearly, because of the size difference, the nucleus big, the little electron small, the nucleus is going to guarantee that the electron is in a whole field, a whole area of no force. So no matter where it moves in that area, it's still going to have the same absence of force hitting it, because the proton, because there's more than one of them, and they're close to each other, is blocking a huge amount of energy from getting to the electron. Alright, let's see. Where do I want to go from there? Yeah, maybe I'll just leave it there. And because I got to do it in a really tedious step-by-step thing, and I thought I was sort of going to do that with this, but it just didn't go that way. Maybe I'll try it one more time. Try to illustrate it or get it to be understood. Alright, so yeah, I really have to go back to the momentum part. So you have the electron. The idea is that you have this thing called momentum, and it has a direction. Kind of figure out, well, just draw the force momentum as an arrow. It's probably the best thing to do. It just makes it clear it has a direction. But what isn't clear is that the electron has in it a bunch of that directionality. That is what it possesses. And it's just, again, one of these consolidation arguments. You could argue that the free universe, this force, has a separation, that there would be force, say, this far apart on average. And inside the electron, you could argue that it's a point particle, in a sense that all of its momentum, all of its, let's say it had 100 of these little arrows in it, all of them are really close together. So all 100 are in one location, essentially. Might as well be thought of as in one location. Just for the, obviously I wouldn't say it has no size, because clearly photons have to hit it. Energy has to hit it, so it can't be a true point particle with no dimensions, because then you couldn't hit it. And that's sort of what physics says, which, it acts like a point particle in the sense that it is so much more compact than the field energy. And I don't even know if that's terribly critical to understand, beyond understanding how it's like a school of fish. I know people hate these kind of analogies, but you sort of understand a school of fish is a compact version of the ocean itself, right? If the school didn't exist, there would be, say, 1,000 fish are in the school. The fish would be all over the place, spread out a certain distance. And what makes the school interesting is the fact that the school, that was sort of interesting, probably should have kept that one, is the fact that they're condensed in a smaller area. And you can sort of understand that once they're in this smaller package, that if another fish flies in, there could be rules about what flies back out again, but the school itself stays what it is. So in a sense, you're really talking about say the school is moving a certain speed, okay, and a fish is going to move in with more speed because it's going the speed of light, and the school is only going 10 miles an hour. It's going to go in with a certain amount of energy, and if it doesn't hit, it could hit a fish going the opposite way right at the beginning, right at the edge of the school, or it could hit one way over here. And where it hits it is sort of important to where the reflection goes, and then what the size of the school is. So the school is just a definition of a certain amount of space and what's in that space. And once it's compressed, the fish can't uncompress the school because all it can do is exchange with one of the compressed locations. So you have to sort of think about the electron as just being a bunch of this force stuff that was somehow compressed, and now exchanges happen, but it can only happen in this compressed space. It can only exchange in the compressed space. It can't exchange into uncompressed space. So whatever happens, you can't undo the compression once you create it. And there's no force. There's no mechanism saying to the school of fish, right? All the fish, once they're in a school, they're all comfortable. They're all saying, I like being in a school. There's no energy forcing them to run away from each other. And so the only thing that happens is they get exchanged. A fish going this way in the school hits a fish going this way from outside the school, and they just reverse their roles. This one decides to leave the school, and this one stays in it. And now the school has a fish going this way, and it lost a fish going this way. So you can sort of understand that the school itself has now more energy moving one way, this way, than it has energy going that way. It changed the balance of energy inside the school. Okay, but the school didn't uncompress because this one went in and this one went out. Alright. Yeah. See, that would probably work as an animation. So I have to, I can do some physical animations. I can make fish and I could move them around. But anyway, I shouldn't have to really, for people who know anything about the subject, and the people who, and they're really the only people you really have to have this conversation with. I mean, I have to have this conversation with physicists. I can't, there's no point in talking to, I'm not saying there's no point in educating Joe Sixpack, but the real point is to point out how this theory is so much better than their garbage. And the only way I can prove that to them is to have the argument, a reasonable argument with them, pointing out how this works so much better than their notions. Alright. Yeah. Okay, so the idea is that so there's always a constant amount of exchanges. So you have to sort of understand this stuff going in, stuff radiating out, stuff going in, stuff radiating out. And all we're really talking about is little bits of extra. So somehow there's a little bit of extra. There's an extra piece of stuff, an extra bit of momentum, and it hits the electron. And as stated, this piece, this bit of momentum going this way hits a piece going the opposite way, and essentially they just reverse roles. This one leaves, and this one stays inside the electron. So now the electron has a bias in this direction, and will move a little bit more in that direction until it loses that bias. Alright, yeah. And so the electron is completely at the will of the force. So that's why the universe would space electrons a certain distance. If that's all there was in the universe, just the electrons and the force, then they would, just by repulsion, just by the fact that if they're closer, they're going to have more reflections, further apart, less reflections, that always the pressure would be equalized. And that's what would happen. And it's only through creating some kind of imbalances that you can change these positions and create some sort of different shape out of the geometry that would be created if that's all there was. And so the key to that, again, is having the opposite particle, the proton, and having it in a shape, a condition, where, because I guess of its size, it being bigger, it was less mobile, and therefore more likely to be the mechanism, the thing getting stuck in the nucleus. Because technically, the nucleus has 2 protons for every silent electron, right? So you have a neutron that has a proton, and you have a proton, and then you have the 1 electron, and that's what's so it has a huge bias on the proton side, and it became the nuclear bit, the thing that would get stuck in the middle, and the electrons would get stuck on the outside, and yeah, just trying to think if there's any, there probably is a mathematical relationship between how many protons there are. Let's say a proton was made out of 3 elements, because they can break protons, quarks they say, and just say a quark was equal to an electron. Then you could make an argument that in the real universe, so we know the nucleus has 2 protons for every electron, and let's say every proton was 3 electron worth, so that would make it 6-to-1 relationship. And then you could argue that maybe the average atom has 6 times more electrons, orbiting it. Okay, then let's see, it'd still be the same number of neutrons. Well, I'd have to think about that, but it might all add up, Cool. I gotta turn the screensaver off when I'm making a video, maybe, or make it less, who knows what's going to pop on the screen kind of thing. Make sure I know what screensaver's loaded. So I'm just using random ones now. But anyway, all right. Well, I shouldn't have bothered trying to see. But I'm just saying, as soon as you start thinking about this stuff, you can start making up, recognizing the other circumstances that could be creating effects, and there could be made an argument that when the electron is being moved, so this is one I can't be sure of yet, so when a bit of force goes in and it hits somewhere, and this reflection happens where a bit of force leaves in the opposite direction, meaning it changed. You can think of it as they hit and they switch directions, or you can just think of it as one goes in and stays, one leaves. It doesn't matter. But the point is there could be a delay in time between when this goes in and when this goes out. And that delay could just be the distance of the electron, in the sense that if this force bit goes in, it doesn't. So here's an electron. It could have its momentum here, as I pointed out, or the momentum bit going this way could be over here. Okay, the one going that way. So obviously, if this goes in and it hits this one, well, then there's going to be an immediate reflection. But if it takes it a while and it hits this one, then you got the time it took it to go through the electron, plus the time it's going to take it to go back, all the way back to get to this point. That's when you're going to see the reflection. So there could be a delay based on the size of the electron. And so that again could have something to do with the frequencies of light and radiation. So it could explain why there seems to be a preference for certain frequencies, and there seems to be a preference from infrared to the edge of ultraviolet, that there's an awful lot of atoms that produce spectra in those frequencies, and that could be just because that's part of how the electrons are moving, and their size has some play in deciding how big the frequency is going to be. And it would also explain things like radio waves are created by a completely different process, in that they're not in ray form. They're a bunch of things. They're a big surface, let's say, pushing something. So it makes, each piece just makes one little bit, one tiny little bit. So a bunch of ones come off. So there's a whole bunch of little fish, and then there's nothing, and then there's a bunch of fish, and then there's nothing. But the individual fish aren't coming from one atom. It's not like a ray of fish coming from one location. It's like one fish from every location, one fish from every location, one fish from every location. So it's being created not in ray form, just as a bunch of soldiers on a field. They're not like cannonballs. They're not coming from one place. But the fact is their impacts are still impacts, and they all happen to add the electrons all at the same time. So all the electrons get hit by a cannonball on the receiving side, and even though they're not in ray form, they're not coming in straight directions, the fact that this is every single electron got hit. So the electrons have a hard time spreading that pressure because they all got pressurized at the same time. So that pressure has to be pushed to some other electron, further deeper into the atom, and that's why you have a different kind of reaction, which is you've now polarized the atoms by pushing on all of them at once. You've pressurized all of them and created a little bit of an electric current. But that gets you, it's getting into a whole other subject, which is really, they're all the same subject, so that's kind of silly to say it's another subject. Gravity, magnetism, electricity shouldn't even be, you can't help but think of them as different things, but they're all just momentum. I mean, it's really hard to think about electricity as being momentum going through a wire, but that's what it is. It really is that literally consistent with what you see. The turbine turns, in one location, has momentum. The momentum goes through the shaft, it goes, into the generator that's moving another magnet. It's just all movement. It's all real momentum, and the momentum actually goes through the wire and it moves through the wire. It's momentum. It's not moving the wire. The force is moving through the wire, but they're almost the same thing. It's almost as literal as having a steel bar connected between two places and hitting it at one end and it moves on the other end. It's almost that literal. Just isn't, but it's almost is. So you have to think about it. That's what electricity is. It's momentum. It's momentum in a direction. It has a direction, and it will ricochet in a direction. It will move in a direction, and it's real momentum in a direction. And like a fiber optic cable, it can be tricked. Okay, it can bounce, reflect off surfaces very efficiently without any losses and change its direction. But it's real momentum. Just like we can take our physical momentum and we can loop into gravity and do a U-turn and not lose anything in the process. Essentially use, I think even the amount of energy it takes to push out of the gravity, just to deflect out of the gravity, is the same energy you got when you got bent into the gravity. So if you stored the energy going up the hill, you can just use that. You can use the brakes to generate the energy you used to get up the hill, theoretically. You can have a very efficient system. That almost brings up a point, right? I mean, if you could make a very efficient system of recovery, so you have a flat road and you try to reduce all the friction with wheels and stuff, so that works pretty good, and you still have air resistance and all this other stuff that stops your motion. So, but it really is just the friction. The friction is the only thing that makes you need a lot of gasoline. Theoretically, you should be able to get kicked here, with a boot. A big boot hits you here, kicks you. You could go all the way, a billion miles if you didn't have the friction. So it's just the friction with the road. So what I was thinking, though, is that you could sort of change this scenario by making a bunch of hills. And the idea is that going down the hill, you would generate electricity, and then you'd use that electricity to go up the next hill, and then you'd generate electricity. And theoretically, that could work. But still, friction's going to get in your way, so you're not going to win. It wouldn't make any difference. So it just popped into my head. That it is a real tendency to sit there and keep thinking oh, there might be a gimmick, where you can get around this stupid thermal equilibrium thing, but you really can't. The thermodynamics is just unyielding. Alright, well, that's probably enough of a video. It's not exactly the video intended, but I think it had some useful elements anyway. But I know I got to make something more compelling and interesting to almost anyone. But again, I need to talk to physicists. I need to talk to somebody who understands some of these concepts and can recognize, or at least make an argument where somehow this violates some sort of law, which it doesn't. Okay, anyway, this simple explanation for the creation of attraction and repulsion. I don't have this piece of paper doesn't have enough red and blue on it, but yeah, it's just what do I do with the drawings? I don't know. I thought I had a pretty good drawing there, and I got rid of it somewhere. Yeah, this one. There, that's the one. Right there. I mean, that explains it all. Trapped reflections and escape valve. That creates every opportunity for every phenomenon that exists in the known universe right there. You end up making low pressure and high pressure in a really simple mechanical system. That's it. That's where it begins. That's where it begins to get interesting. Now, obviously, what creates electrons and what creates protons is probably another subject, but I don't know how interesting that would be, because it's probably something that just has to do with that consolidation thing, compressing something. So it's probably just some sort of byproduct of compression. It's what happens when you start putting a lot of energy in a small location, which you can only do with electrons and protons. So again, that's where what came first. Where's the chicken and where's the egg? But I would argue there's probably some other mechanism that I mean, this is the stuff that created atoms. Electrons and protons made atoms. There's something that made electrons and protons. But I don't think it's terribly important to know that, because once you know this, you know everything that's really functional and working. This is the story of attraction and repulsion, and that's the story of everything. It's really just repulsion. It's not, again, it's not attraction. Things are always pushed, so it's just about removing, pushing pressure on the inside and putting it on the outside. But it's always push. Anyway, enough, I think. Oh, I'm going to say it's enough. Yeah, that's what I'll do. So, till the next time. And such.